Angelina Sapola, and today we're going to be learning about surface area. So let's start off with just two quick definitions. The surface area is the area of an object's net. And now we need to know what a net is. A net is a two-dimensional pattern that folds into a three-dimensional solid. So a net is 2D, while the three-dimensional solid. So I'm going to show you some examples of what that would look like. Starting off with a cube. So we have a cube. Sometimes we have dice. A dice is an example of a cube. So it has 6 sides. And we're going to talk about surface area. So to get this surface area, we need the area of each of the surfaces. So there's 6 surfaces, but it's kind of maybe hard to visualize. So we're going to get a net of it. So we're going to take this out and see that we have our cube. And then we're going to fold it into a net. And we see our 6 faces that make up the one prism. And this is a cube, but it's a special type of rectangular prism because all of the faces have equal measure, which also means they have equal surface area. Let's look at a real rectangular prism. We know this is a rectangular prism because the base tells us what kind of prism it is. We know that it's a prism because the bases have the same shape. So we can open this up, look at the net, and we see that it's a 2D, it's flat, it's not a 3D figure, but it represents what the 3D would be. So you say, what's the purpose of surface area? If I find the surface area of this rectangular prism, I know how much I need to completely cover it. So if I'm going to wrap a present, I can know how much exact wrapping paper amounts I need to cover it completely, how many square feet. Alright, let's look at another prism. Here we have a prism. We've talked about a rectangular prism with the base of a rectangle. We had a cube where they're all the same, all the faces were the same. Now this one, we can't tell what kind it is until we look at the base, because we look at the base, that's what tells us what kind of prism this is. We look at the base, we can see that it has 6 sides, which makes this a hexagon. So this is a hexagonal prism. So we take it out, and we can see that we have a net. It's flat, a net. We have 6 rectangles that match up with each of the sides, and then we have 2 hexagons. So to get the surface area of this, we would be able to get this area of each one of the faces. So rectangles, you can do that, base times height. Hexagon, you might think, I don't know how to get the area of a hexagon. You can decompose this into triangles, and then you're good. You know how to do it. Let's look at our last prism. This is a triangular prism because the base is a triangle. We can take out the net. And here we see our triangular prism net. It folds together. This is our solid. This is our net. And we would get the area of each of these. And since this is an equilateral triangle, which means they're equal on each of the sides, these are going to be equal in measures also because they fold together. So these are all going to have the same area as well. We can look for shortcuts because we're lazy mathematicians sometimes. Now we have a pyramid. So in the prisms, they have the same bases. Like this one, we have a base of a triangle, triangular prism. This is a pyramid because it doesn't have a matching one on top. It has a point. What kind of pyramid? Triangular pyramid. When we take it out, we can look at our net, and then we would get the area of each face to get the surface area of the whole triangular pyramid. Now let's look at a square pyramid. We don't get the volume of pyramids in 6th grade, but we can get the surface area, because to get the surface area, you just need to know how to get the area of each shape and then add them together. This is a square pyramid because the base tells us it's a square. We open it up, and we see the net. There it is. And this would tell us, we get the surface area, how much we would need to cover it. So if I have a pyramid and I want to cover it completely, I want to paint it or wrap it, I know how much paint I would need or wrapping paper I would need based on the surface area. So these are really cool examples, but let's look at numbers because that might help us out a lot. Okay, so here we have a rectangular prism, and if we were finding the volume, you could find the volume of this super easy, but we're not finding the volume, we're finding the surface area. So when I'm looking at this, I have to remember rectangular prisms, they have 6 faces. Like our rectangular prism here, there's the 4 and the 2, one on top, one on bottom. It's easy to forget a face when we're looking at this, so let's make a net to help us visualize what's going on. So we have our rectangular faces. So we're going to do like this is our rectangular faces. And then we have the top and the bottom. Forgive my drawing. Okay, we know that the bases here is a 6 by 8. So let's look at 6 by 8, which also means this is a 6 by 8. And then we need to figure out what are the dimensions of our rectangles. So if we look here, this side, if we're looking at this shape, this rectangle is 8 by 14. So we're going to need to do this as an 8 by 14. And I know that it's going to be, this one is an 8 because when my rectangle, my net folds to make a solid, this line and this line match up. So if we look at this, it's not exactly the same. But the one that's right beside it, they're going to fold together to make the net, from the net to the solid. So they have to match. So this one's going to be 8 by 14. These are 6 by 8. If this one's 8 by 14, the opposite side has to also be 8 by 14, which would be here. Now if this one is 6, this is 6. So our other faces are 6 by 14. And we can see that over here too. This one is 6 by 14. So our front and our backs are 6 by 14. So this is kind of like the front of my rectangle, this is the back of my rectangle, and this is the top and the bottom, and then those are the sides. So let's put this down. Let's make this a little bit shorter. So surface area is the area of all the surfaces, but I can say, hey, some of these surfaces are the same. Like this is a 6 by 8, this is a 6 by 8, so I'm going to do 2 times 6 by 8 to make it a little bit easier for me. And then next we'll do 2 by 8 times 14 because we have 2 of them. The next we'll do 2 times 6 by 14. So we have 2 times 6 by 8, which is this. We have 2 of them. 8 by 14, 2 of them. 6 by 14, 2 of them. And now we've covered all of our surfaces. So let's multiply this out. 6 times 8 is 48. 8 by 14, if you're thinking, ooh, 8 by 14, you can do scratch work up here. So that's going to be 32, 11, so that's going to be 112. 6 by 14, again, you can use space for scratch work. That's going to be 24, 84. So 2 times 84. Now we're not finished yet. We have to take it down to the next level. So we go by next. 2 times 48. That's going to get us to 96. Plus 2 times 112 is going to get us to 224. And then we have this, which is 168. Then we need to add those together. I'm going to combine these two first, my preference. So I'm going to do 224 plus 96. It's going to give me 330. All right. Oops, sorry. 320. And then plus 168. I ran out of room. 488. So, sorry, my steps got really messy. But 488, then I'm going to look at my units, which is meters, and since I'm finding surface area, it's going to be meters squared. So here's my surface area of this rectangular prism, which tells me if I want to wrap this rectangular prism, I need to have 488 square meters of wrapping paper to cover it. And when you buy wrapping paper around the holidays, it'll say this is 300 square feet, this is 400 square feet, so you know how much wrapping paper you're getting. I don't know many people that measure all of their Christmas presents before they buy wrapping paper, but you could do that if you wanted to. Let's look at another example. Here we have a prism, not a prism. Here we have a pyramid, and we know that it's a pyramid because it doesn't have a matching bottom and top, right? Like on our prisms, we have matching bottoms and tops. This is our rectangular prism, but this is a pyramid because they all come to a point, and we have a square on the bottom. This is a square base, so this is a square pyramid. So let's first draw a net of it to help us visualize. We have our square base. We have triangles from each side, and the triangles are going to fold up to make the pyramid. So here, this is a much better drawing, but the sides all fold up to give us the solid, which is a square pyramid. Now let's put our measures. Our base is a 4 by 4, which is a square, and then we don't need the height of the actual pyramid. We need the height of our triangle. So that's the lateral height, and in 6th grade they give that to us. So they're saying that the height is 5. So in my shape here I have 1 square and I have 4 triangles. So my area of a square is base times height. And then I'm going to be adding the area of a triangle is base times height divided by 2, or times 1/2. So my square is going to be 4 by 4. My triangles is going to be 4. My base, 4. My height, 5 times 1/2. Okay? So now we have 16 plus 4 times 20 times 1/2, or 20 divided by 2 would be 10. So that's 16 plus 40, which equals 56 feet squared. So it's really, really important when we're finding surface area that you show your work and you show your steps. See how this is kind of clear? We can see where I'm starting with. Now I'm plugging in, okay, my square is here, my triangle is here. And sometimes, like on our last example, there's a lot of work, and it's all there. But it's easy to make little mistakes. So when you're doing your work, make sure you show all of your steps, and then you can go back and say, oh, that's where I messed up. I forgot to divide by 2. Or I left out one of the shapes. So if you do that, it helps finding the surface area. And now that you know the surface area, you know what amount it takes to cover any object. Surface area, covering. Volume, that we've talked about before, or that we will continue to talk about, talks about filling. Volume, filling, surface area, covering.